Hello, good morning, good afternoon, good evening.
Yeah, I look at.
People who are comfortable with their camera on for this meeting, that would be a good thing, even though I know we generally don't for the TSCs. And the reason is you just connect better as a person if you can see what's going on with the other person. Andre, how are you? It's good to see your face and connect a person to that name.
Hi. I'm delighted to meet you guys. Yeah.
We don't have built into the timeline for this meeting waiting 5 minutes to start. But we do have a little bit of slack time in the Q&A. And I think we do have the leeway to give ourselves a moment to get started.
Hello, everyone.
Hello, how are you, Jordan?
Hello, Jordan.
Good, good, good.
I will be the moderator for this, which mainly means telling people when time is up. Or I'll go like this or something.
Yeah.
Or,
Or you can interrupt us.
or interrupt you. That's the other thing. Yeah. Well, speaking of that, I think we have enough people here to get started. Has everybody agreed?
Yes, I think so. But we should give them 1 more minute. Let's give them 3 minutes. Because I also had some issue connecting. It took me at least a minute and a half to figure it out. Too many links, too many logins, and too much security.
A lot of links and logins.
And I don't see we are yeah, we are recording it. Okay, good.
And this meeting will be the first on the YouTube channel.
Oh, okay. That's cool.
Yeah.
So, yeah, so this is gonna be the first one public on YouTube after 2, 3 years, I think it's been. So,
That's good.
Jordan, I know you wanted there for the last THC, but we said last THC we stated that all the recordings for all the meetings are recorded in YouTube, but only the community ones will be public. So that's
Okay,
what
but
that's
that's good. That's very good. That's very good. Okay, I think we can start, Lucas.
Agreed. Thank you to Mickey for arranging all this, and over to Jordan for the introduction.
Yeah, and I think you will share my slides, or shall I share my slides? Lucas, will you share the
You're good?
slides? Yeah.
I thought you were doing it. It'll just take me a second.
I was.
Go ahead.
Usually we have the moderator, or let me
Okay.
share the slides.
Oh.
No, it's okay, it's okay, it's okay. Yeah, and I don't have share here. Yeah, that's the issue. I'm not allowed to share.
You should be allowed to share. And I will reset the
Yeah,
timer.
I'm allowed to share. Good. So let's go. Can you see my screen?
Yes.
Okay, good. Let me see if I can figure out how to put this in presentation mode. If not, we will go like this. Okay, so let us go like this. My intention here is to recap from the previous town hall what we were discussing in the version 1.10. What we want to see in the version 1.10, and then I'm going to show you which one of the initiatives are currently in progress, and then who is leading this initiative. So if people want to contribute these initiatives, please contact the person who is leading the initiative, and then for sure we will try to figure out a way how you can contribute to the community on these initiatives. So on the version 1.10, we were saying that we want in that version to have alignment with the 3GPP 17 because we are lagging behind the releases. We are currently compliant only up to 16, release 16, very early release 16. So we need to move to release 17. Then we were saying that we want to do the migration of remaining items which are in Python to migrate them to C++. But still leave ability for them to be flexible enough for entry-level developers or contributors to try to create their own solutions or try to modify the solutions and do the experiments with the system. Then we were saying that we are going to change the documentation and improve the simulation tools. So this is once again overview of the slides which we have presented last time. We are still pushing release 1.10. Previously it was planned for Q4 2025. I'm pushing it for Q2 2026. As we are still not we have still not stabilized the full CI/CD pipeline, we might push it even further. But on general, so this is we are going to R17. We are improving the operational features, and we are going to migrate the things to C++ in order to allow us to actually move this to the release 17 and improve the deployment. And we are aspiring to move the eBPF to move to eBPF based GTP tunnels. So currently, what's the progress? The migration of the pipeline started. We already had some demos, some things which we have run as the proof of concept for some of the libraries which we are going to use. We have created the design. The design is created as a modular framework. Very soon we are going to publish this design to the community. And then most probably on the, not this, but the town hall afterwards, we are going to show you some of the things which are as work in progress done on the migration to the C++ for the pipeline D. And if somebody wants to contribute, I'm leading this initiative, so please come and connect with me so we can discuss the contribution in this initiative. We have the next initiative, which is already in progress, is the enhancements of the simulation tools. And we want to adopt the Packet Rusher as a 5G integration and testing framework. And that initiative is already in progress by Lucas Amaral, and he's going to show today some of this work in his talk. So contact Lucas if you want to help on that initiative. The next initiative is the migration to the from current Ubuntu 20.04 to 22.04 as a stepping stone to move to 24.04. There are some things which were already done on the orchestrator to uplift the orchestrator, but big lifting work needs to go on the AGW. And Miki Kumar is leading this initiative. So if somebody wants to contribute and help, please talk to Miki. And then we have the enhancements of the tools for the deployment. We are going to separate the deployment from the main repository in the same way that we were separating the documents from the repository. And we will enhance the tools. The whole idea is to have one-click install. Currently, because we are lagging behind the releases of Ubuntu, even the one-click installs which are used to work, they are problematic. So you need lots of preparation for that one-click to work. So it's pre-scripting and then one-click works. But we are aspiring to make sure that for all case scenarios, for all type of deployments, one-click works. And all the scenarios and all type of deployments are using the same or similar deployment scripts in order to minimize the possibility, the types of changes which are required. And then finally, the documentation, project is already in progress, and that's also driven by Lucas Amaral. So Lucas will speak a little bit later about that. If somebody wants to join the documentation project, and on the documentation project, by the way, we have seen lots of people joining and contributing. So that's a big success for the community contributions. So Lucas Amaral is going to talk a little bit about that. Standard slide, which I show always how to get involved. We have the Slack channel, we have the calendar, which you can follow the events. And then we have the GitHub and Wiki. So please, anybody, whoever wants to contribute, test, learn something about Magma itself, join, talk to us. We are more than happy to talk to all of you and help you with your journey to Magma, either being deployment or development, research, whatever you want. So with this, I have finished my slides. We will have the Q&A after the whole talks. So anybody else having any questions, you can just talk. You can just open them after the everybody's talk. And back to you, Lucas. I think I didn't broke my time.
Thank you. And there's plenty to talk about there. Could you take the screen share off?
Didn't I? I think
No,
I did.
yes, you did. Okay,
Mhm.
so I'm going to talk about first the large scale picture of how we're growing. There are roughly 4 big things going on in the Magma Core project. First of all, there are architectural improvements in the engine. Secondly, we are breaking apart our release schedule and our release strategy, and as part of that, breaking apart repos. And this will have the benefit of making it easier to get a PR in, and a really big change in how we release stuff. More things will be going out the door. There's more to say about that. The community is growing really well. There are a bunch of new people here. We're really glad to see you, and thank you. It makes a big difference. And not only people who are here, but also internationally. Magma Core continues to thrive in new places. And lastly, convergence. So what do these things mean? So these are the architectural improvements in the engine. Here we're talking about what's going on in 1.10. They're the items that Jordan flagged just now. We intend to release 1.10 in Q4, so get it out the door by December, and that means testing complete. The theme of that is it's an all Docker release. Would not be physically possible without Docker, and we're going to talk more about what those architectural changes are specifically over the course of this meeting. 1.11 is a small release that is not as large, and ideally would be at the end of the first quarter in 2026. And the items in 1.11 will make it possible to have a bare metal Debian without Docker. And we'll talk more about those details and actually have community involvement in feature ideas. And then 1.11 would be roughly Q3 2026. More to say about that. But roughly the theme would be Linux Foundation connectivity convergence. And that comes sort of from a conversation with Shah, and we've kind of started talking about it, but there's a lot more to say, and obviously we're community driven. So what does it mean that we have autonomous releases, right? Going back to this second item in the tectonic motion slide. The starter kit, these are all-in-one Magma, base stations, and that can be released and improved on an incremental basis without changing everything else. There will probably be a team in India working on it with Nitin coordinating. The documentation group is able to do releases outside of the core repo right now, although we're not 100% sure on how we'll do that. The deployers, so the Magma deployers repository is a separate repo and is able to make big improvements. And in general, the refactoring of the mono repo is a critical piece of that. We have community growth. The mentorship program is going great, especially thanks to Lucas Amaral and Mickey Kumar for making that happen, and everybody here who is joining us through that. Autonomous communities, we're semi-autonomous communities in places like India and Brazil are growing really well. And we in this group are creating supporting infrastructure such as the deployers and documentation. Lastly, the convergence milestone coming after 1.11 would roughly be things related to Linux Foundation connectivity. So that is these items. One of them in particular, and when we'll talk more about these and another item later in this roadmap, later in this presentation. Okay, it's 11:16 and we are perfectly on time. That's it for me. I have a couple minutes, but I think we should jump into a conversation on Magma India. Just keep going through until we get to the Q&A. I will stop the share. People okay? Was there anything critical that I should address right away before we jump to the next presentation? Was that too fast? Okay.
No, you
Neaton Rajput.
Let me share my screen. So, is it visible? Okay.
Yeah.
So, so hello everyone. I am Nitin Rajput, the CEO of Coral Labs and the TSC member in Magma India, and also an organizer in Magma India community. And I am today going to talk on behalf of Magma India community. And we have been actively working to extend Magma's capabilities. So today I will be sharing the updates on 4 key initiatives led by the Magma India. So first is Magma integration with interoperable ORAN ecosystem. Then after that, I will cover Charmed Magma AGW. Then the PQC integration in Magma, and after that, eBPF based GDP in Magma. So first, let me cover the interoperable open RAN ecosystem with Magma. So we are currently doing testing with the Magma as in 5G core, and after that, we have multiple L1, or you can say multiple CU vendors like OEICU, SRN7CU. Then we have multiple N2 vendor, and we have XFABRI that's connect multiple L2 and N1. Then we have on L1 side, we have a NVIDIA Aerial, Intel FlexRAN, and OEI L1, and any other L1. Then we have a OpenMplane, which is another project by LFC on the Mplane. Then we have commercial radios like Lighton, Benetel, Acton. These are all ORAN compliant commercial radios, and we have done testing the Magma core with this all commercial radios, and also with the SDRs like X410, N310, B210, and so on. And top of that, we have a SMO and the rigs like non-arteric and near-arteric. So this is the completely interoperable open RAN ecosystem that we are testing with Magma and making it more vendor agnostic. So this diagram basically depicts the Magma cloud native architecture that we have already tested. Like you can see the Magma component on the Kubernetes side, and we have tested with OEI, SRSN, and the interoperable, ORAN stack that I have covered in the last slide. We have connected it with the Grandmaster, which is a synchronizer. Then we have a commercial radio and the quad CV that we have tested, and SMO and RIC also. So this is the end-to-end interoperable stack that we have tested, and I have already shown the demo in the last community meet. So I will share the link over here so that everyone can see. So briefly give the overview what we have done. So we have a Magma core as a 5G core, and we have deployed it on server 1. Then we have a OEICU on 2. Then we have a different L2 connected with the OEICU, that is OSCDU. XORP, which connects with the OECDO and OEIL1. Then we have commercial radio. We have used is Lighton. Then we have tested with Chordsui. So this is already tested end-to-end. Then we have working on the Charm Magma Access Gateway. So we are focusing on operational excellence by integrating the Magma AGW as a charmed operator using the Canonical's Juju. So with this, the each components of Magma AGW like MMEs, SND, pipeline D, mobility D, subscriber DB, and etc. is deployed as a Juju managed service. So we gain the declarative, repetitive deployment, lifecycle management, like upgradation, scale, relate between the Magma AGW components and built-in observability. So this design can work on the LXC and the bare metal also. So this drastically simplifies the orchestration for telecom, providers through the Magma, and it aligns the Magma with cloud native automation principle. So now let me give you a brief overview of what PQC in Magma. So as a quantum computing advances, so current encryption like RSA and ECC are becoming vulnerable. To address this, so we are integrating post-quantum cryptography in Magma. So we are currently prototyping with MLChem Kyber for key exchange and MLDSA for digital signature. So we have already tested different PQC implementation in 5G core and RAN, and we have a project like QRE, which is a post-quantum 5G core, and QRAN, which is post-quantum QRAN. So we have already tested in our lab, and we have different PQC implementation over there, which is PQTLS, PQO, DTLS, PQDTLS, and we have also tested with PQ-IPsec between the 5G core and the G-Node. So we were planning to integrate those implementation, PQ implementation in Magma also. So this will be the hybrid approach. We will have a classic and PQ-based crypto also in the Magma. So now we have a eBPF-based GTP integration. So so we are finally modernizing the user plane by replacing the legacy patch GTP kernel module with the eBPF based data path. So to give a deep dive into our eBPF implementation, I would like to invite Shiva, who is a community member in Magma and leading these initiatives, to walk you through the technical detail. So Shiva.
Yes. Hi, I'm Shiva Walia. I am working on the eBPF-based data path solution of Magma right now. Our current approach and aim is to remove the GTP kernel module, which is currently used by Magma's current data path. The reason we are removing the GTP kernel module as it restricts the Magma as a component to become a cloud native based solution, right? So we will be introducing our eBPF programs, which will perform the tasks of decapsulation and encapsulation as currently done by the GTP kernel module, and we'll be attaching our programs on our created virtual interfaces as we see in the diagram. So to give you a packet flow, let's walk you through the diagram currently. So the first packet will move, packet will come to the physical interface. After that, we will classify the packets by this TC ingress filter, which will classify the packets based on its type. So for the type like GTP, UDP packets, we will forward it to our created GTP WETH1, which is our virtual interface. And here we will be attaching our eBPF programs where the real functionality of encapsulation and decapsulation will happen, and we will forward it to GTP WETH0, which will further forward our packet to the OVS bridge, which will pass it to the OVS. And we do not plan to change anything other than that in the overall stack, because our main aim and purpose is to just remove the kernel dependency as the remove the kernel GTP module, which restricts our whole Magma data path to go from cloud native based. And similarly, similarly for the encapsulation part, like from the for the ingress flow, we will use the same encapsulation program in our TC eBPF. So our aim is just to remove the GTP kernel module right now, and hopefully we will be able to do that. Thank you.
So we are already working on this. Most of the things are already done, and for the community, the issue is already created on the GitHub. If anyone want to see what was the approach and what was going on, so it was already on GitHub. You can go through and this approach is already approved by the TSC. So this was all from our side. Thank you.
Thank you.
Over to you.
Next, Mickey Kumar on the mentorship program.
Yes, give me 1 second to find my screen. Wait me. Okay. Can you see my screen?
Yes.
All right, thanks. All right, just to get started, as many of you have known that we started the mentorship program piloted by and supported by Linux Foundation. So this is something new we have brought into Magma as part of the outreach support and community growth. So why Magma? So the reason why we chose Magma and decided to bring the mentorship program is because of the innovation, building, and long-term stability of basically open source 5G ecosystem. And as many of the big companies, we are moving to more open source 5G. So that could include Telus, Bell, Rogers in the US. There's even a couple over there that's looking, but still, it's our target where we've been seeing a lot of Brazil trying out Magma as well. So that's where the mentorship program will come in because it will help with the innovations in the cloud with that. And also as a highly technical and a community-driven initiative. That's the main thing. As the mentorship will help grow the community-driven initiative. And again, Magma has a strong pipeline of skilled contributors from web developers to technicals to like 12 mid, 12 ops, and also helping with the architecture in the future. So as part of the mentorship, what's the benefit for the mentees? So mentees will get a real world experience within the telecom system and world. They will have collaborations with the engineers all across the world, and this will also help them build their network on a global scale. It helps with like get the credibility with the open source and the telecom community from Magma to OLAN to all could be ONAP. All these community would slowly transition to the 5G ecosystem where you would meet and be visible in all these community. And for the mentees, they will also have a clear code leadership development slowly for transition. So based on our application, we have received 113 people that applied for the pilot program for Magma's mentorship, which is running from now till end of November. And 27 has been accepted. It's as you see in the image again, it tells that we could be providing like knowledge transfer, community growth will happen, code quality will be helping. The project and stability will also be there because of the mentorship program. And of course, onboarding new mind and how to take Magma forward. Yep. And that's all for right now. So if you have any questions or anything, just let me know and we'll take it forward. Thank you.
Well timed. You reached your last slide at exactly the right moment. Respect to you.
I try, yeah.
Next, yeah. Next over to Jim B on Magma Dash Deployer.
Would
Jim,
we
did I say
need the
Blakely or Black?
documentation?
Pardon?
Oh, I'm sorry. I am wrong about that. Jim, I'm sorry. I jumped the gun. You'll have to wait a couple minutes. Over to Lucas Amaral on documentation.
Yeah, that's what I thought. Okay, go ahead, Lucas.
Sure. For the Magma documentation project, first, bringing some context here. Magma powers open source 4G and 5G and Wi-Fi networks, and a clear documentation enables a faster onboarding for new users and contributors, easier deployment and management of Magma networks, and community growth through accessible knowledge. As far as the documentation working group goes, we have progressed into creating a new Magma documentation repository in March with the intent to translate the documentation to other languages, such as Portuguese, Spanish, and Hindi by native speakers to attract new contributors. This translation was postponed until the documentation refactoring. We still have the discussions on properly planning and executing the translation. We have upgraded the Docusaurus version and updated its configuration. We have fixed broken internal references and linting. We have introduced a couple CI checks on the new repository, and we have already started reorganizing and reviewing the documentation currently present today. For the review and organization of the documentation, we have been discussing this in the issue number 18 of the documentation repository. And basically the goals are to ease the learning curve for users and contributors and simplify maintenance to keep content current. As of the plan, we intend to separate the documentation by intent, which means there will be sections for deployment, configuration, use cases, tutorials, and technical reference. So a user with a specific goal can reach the part of the documentation that is applicable for his situation right away. And we also plan on progressively educating the users with links to the technical references applicable to the step he's trying to perform. The main impact for the Magma users is to simplify onboarding for telecom engineers deploying 4G and 5G networks, reducing errors with clear and up-to-date guides, encourage global contributions through multilingual support, which is planned, not in execution as of right now, and it aligns with Magma missions of accessible, scalable networks. I'd like to give a huge shout out to Gabriel Nóbrega, Jorge Vargas, Breno Miranda, Rafael, Daniel, Kidos Paulos, and Andrew Mbugua. They have been interacting with the documentation working group so far. Again, join Magma community, collaborate with global experts, and shape the future of open source networking. Join the Slack channel and share your use cases and explore the documentation. If you'd like to reach out to me, join the Slack channel and search for my name over there, Lucas Amaral. Thank you.
Thank you, Lucas. I want to call out that documentation is one of the things that new contributors most need, and also one of the things that new contributors are best positioned to make improvements to. So as you're onboarding and figuring out a fairly tough learning curve, take notes, use your experience to make it easier for the people who follow after you. And now over to Jim Blakely, as originally planned, on the deployer project.
Thanks, Lucas, and Lucas Amaral. That's a great lead into my talk as well. I come from a background of actually trying to deploy Magma in real networks. And in that, we've learned a number of things about how to go about deploying it. One of the systems repos that was created back at around the 1.8 timeframe was something called Magma Deployer. And Magma Deployer originally was a quick and easy way to deploy the Magma orchestrator. As part of our efforts to roll out our 5G network here at Carnegie Mellon, we enhanced that recipe to include deployment of the AGW as well, using the using the Docker Compose version of the 1.9, 1.8 and 1.9 releases. So one of the things we learned in that process was that deployments, first of all, need to move fast. You know, you need to be able to get a network up quickly. You may need to clone AGWs frequently, both to serve different areas as well as to just do different versions of the AGW for different releases. And doing so on top of the deployment tools that are released with the platform itself was a little too cumbersome and slow and difficult to do. And so Magma Deployer emerged as a place to put recipes for deployment to speed it up. So it has been sort of an ad hoc repo for the last couple of years with very few users. We've decided to expand it and improve it such that it can be a platform for the whole community to use. And it differs from the mainline Magna Core deployment tools in that it is expected to be customized. It is expected to come in many different flavors for different releases, for different potential landing zone environments. And so right now it is fairly limited. I put in the links in the chat to the information that you can find on it now. But I'm looking for help to, first of all, get the current recipes up and running in a way that is robust and can be moved between one release and the next. And also to cover some of the things that we haven't already covered. Two of the biggest ones right on the plate right now is integrating the Kubernetes launch of the AGW into as a recipe for actual deployers. Some people have done that deploying it. I did some pre 1.9. I know Connect 5G has been doing some recently as well, but we really want to get a recipe in place to be able to support deployers who want to do K8's deployments quickly. The other one is, you know, part of the process of bringing up a network is connecting UEs and RANs to the network. And so one project we would like to get going is the ability to use UE RANSIM as a key component of the deployment of a recipe. Now, in the real world, you use a real G node B or E node B and a real UE. But during the bring up process, being able to test with UE RANSIM is a good step in the process. So those are probably the two biggest projects we're looking to get going, as well as the cleanup. And then the other part of it is looking to the community to suggest and in fact develop recipes that they would like to, that they've done themselves in their own environment, that they would like to share with the broader community. It will take us a little bit of time to get going. We're going to use the mentorship program and the documentation work that Lucas has done, Lucas and his team have done over the last 6 months or so to help us jumpstart some of this. But we're really looking for contributors and mentees who want to work on the Magma Deployer project. If you have more questions, we can get to them in the Q&A section. Thanks. Back to you, Lucas.
Jim, thank you. And let me call out that the deployers have some of the simpler and more approachable code and are, you know, particularly amenable for new contributors. So the next segment will be Lucas Amaral talking about the Packet Rusher project.
Packet Crusher is a 5G UE and G-Node-B simulator and load tester. Why use Packet Crusher? First of all, it's an open source tool, so there is no cost involved on using. It can be used to validate 5G control plane procedures, the signaling, validate the correct operation of the user plane traffic, measure and stress test the core's user plane throughput, and ensure reliable high-performance 5G networks. At the end of the day, it saves times and reduce costs. What are Packet Crusher's practical use cases? To validate the Magma installation, which means to confirm a Magma 5G core is fully functional on the signaling and traffic, to test new features, ensuring features under development work without breaking the core. And for 5G networks, it might stress test low latency signaling for dense deployments and stress test high throughput traffic for data intensive applications. What are the main features of the Packet Crusher? It allows you to run multiple UEs and G-Node-B simulation from a single command. It has an automatic pickup, capture, and export. It allows you to use multiple PDUs per UE. It supports roaming and handover. It has been reported 5 gigabytes per second on traffic by simulated UE by the Packet Crusher team, which means the Hewlett-Packard. And it relies on the free 5GC GTP 5G kernel module, which also ensures Magma is adherent to the 3GPP specifications against a different library. And automated testing with custom scenarios based on WebAssembly. This particular feature is interesting to integrate with Magma CI to make sure everything works and we have end-to-end testing with Packet Crusher. Coming soon, Packet Crusher, I've been developing IPv6 support. Packet Crusher does not implement it by default as of right now. And I have been developing this feature. It still needs some testing, and it might come on the 1.10 release of Magma. The WebAssembly automation, Packet Crusher provides a WebAssembly structure to programmatically configure test cases and procedures. This is particularly useful for CI pipelines to ensure non-breaking changes occur in the development cycle. To install Packet Crusher, the installation procedure is quite easy and quick. In about 5 minutes, you have installed all the dependencies and built the Packet Crusher binary. So basically, you need to install some dependencies with apt, then install Golang, clone the repository, build the GTP 5G kernel, and build the Packet Crusher using the Go binary. Then you can simply execute the Packet Crusher binary. After building the Packet Crusher binary, we go to the config YAML file for configuration. And the most information that needs to be updated in this file is the G-Node-B N2 and N3 IP addresses, PLMN, TAC, and slice used by G-Node-B, the provision PLMNs and MSINs, which makes the IMSI for subscriber registration, the secret key and OPC credentials for subscriber authentication, and the slice used by the subscriber, and the AMF N2 IP address. After that, we can execute the Packet Crusher. It supports multiple execution modes. The simplest operations is by using the Packet Crusher UE option. And the full-featured one is the multi-UE. To make the full test with PDU section and networking capabilities, we can execute Packet Crusher with the multi-UE /N1 to start only one subscriber. /T to create GTP tunnel for UE. The D option creates a dedicated gnode B for each UE. And then to dump a pickup on the directory, on the parent directory. I have brought here an example on running the packet rusher to see that it's fairly quick. And then we have an IP from the Magma, and we can validate the traffic using different methods. The one the packet rusher suggests us to use originally is by running this command over here, the sudo IP vrf exec vrf and the number of the UE. But since it creates the vol interface, which is through it creates a tunnel, we can also access it directly with the interface setting on the ping command as well. The traffic goes through the tunnel the same way. The benefits for the packet rusher for Magma users, it simplifies 5G core validation for telecom engineers after deployment, ensures reliable high throughput Magma deployments, ensure reliability on development cycles, and provides an easy to set up benchmarking for user plane improvements as well. Again, join Magma community, share your use case, try packet rusher, and thank you. Join Magma.
Thank you. That is very much apropos for what we're about to talk about, which is the 1.11 roadmap. And so this is where we get to be a little bit more speculative and a little bit less kind of brass tacks. So to recap the roadmap, in 1.10, we are going to fix the kernel issues and make it possible to run under Ubuntu 24.04. We'll stop being trapped on Ubuntu 20.04. In but we'll really be tied to this Docker-centric architecture. We won't be able to live without it. So here we're going to talk about what we might do next. 1.10, by the way, is Q4 2025. So the next 4 months. What are we doing after that? There we go. So here are a bunch of ideas, and this is more of a invitation to contribute and a lead into the Q&A. So what we're definitely doing is moving outside of the Docker-centric architecture, making it possible to run in native bare metal Debian, so that we will run in Ubuntu 24.04 without Docker containers. It'll be possible to build a Debian package, is rather what I would say. And we have these other ideas on deck for what to do next. Packet Rusher fits in both to Jordan's original slides, talking about delayed items as improved testing and simulation tools, and is a natural for that goal. We've been talking about switching to Docker Hub for artifacts instead of JFrog. Although Veltris has kind of pushed back in that, I'm not sure that's going to happen. I think handover remains an issue. NB-IoT is relevant to growth in the academic community and community growth. Carrier Wi-Fi is on deck via, first of all, just being extremely relevant as a feature, and through a very practical proposal from Mickey Kumar. We want to deprecate
Here's a
stuff.
concise summary of the provided text.
Thank
Handover
you.
remains in it.
We want to deprecate stuff, get rid of a lot of old dead modules. We want to figure out our support policy for old versions. 1.9 is going to remain an issue. It'll remain the most commonly deployed version for a while. And 3GPP R17, this is the place where we would start to work on it. There's a lot to talk about here. I invite you to contribute thoughts. And with that, let's move to the Q&A. We have 10 minutes left, and I'm just going to open the floor.
I mean, there were some questions which I was looking at them in the chat. So Christopher had a question. Is there a provision to simply deploy Magma components using Helm charts without using wrapper on the top, like Ansible, roll, or transform? So Jim, maybe you can reiterate your answer here.
Yeah, and I will actually add one more thing that I didn't say in the chat, which is if you want to directly deploy using Helm or in the Docker case, Docker Compose, you're more than free to do that. And that's the way that the services all get deployed when you use Kubernetes or Docker respectively for your deployment. There are a lot of things for those of you who have deployed Magma. There are a lot of things that happen before that. So my big bugaboo, for example, is configuring the two network interfaces on the AGW correctly. And so, that Magma deployer uses Ansible for doing all those sorts of tasks, putting the certificates in the right place, and so on and so forth. So, and it also, to simplify things a bit, will do the Helm deployments or Docker Compose deployments as part of the deployment as well. But there's nothing that prevents you from doing it hands-on yourself.
Correct. And I would add to that is the same containers which will run into a Docker Compose or in a Kubernetes. So the containers have not changed. And that means that somebody can even try to use Podman for the deployment. That should be possible as well. Or even unpackage the containers and do the bare metal deployment. That should be possible as well. So the fact that we are not having at the moment deployers for that way of deploying it doesn't mean that it's not possible. And if somebody wants to work on them and contribute them to the community, please.
Yeah, so the reason why I raised this is that, yeah, I've checked in the previous, I don't know of the current status, right? But following some of the Ansible stuff might be a little bit to troubleshoot them just in case if you run into issues, right? So that was why I was like, not everybody will want to like use the Ansible way or the Terraform way, right? So all the components, I've checked all the components, they are also normal Kubernetes applications, right?
Yeah.
So
Correct.
it's I mean, I could want to like just do the prerequisites on my own cluster the way and then get those values and then just like feed them into
Yes.
yeah. So but I don't know if there is maybe there is a documentation
There
that
is
just
there is no documentation about that type of deployment, but it's something that you can do because we in a Connect 5G we did it before. So you can just follow the Ansible and get the commands, extract them, and then use whatever type of script you want to put them in. And the only thing which, as Jim mentioned rightly, the only problematic thing or the only critical thing which you need to pay attention to is the deployment of the interfaces and deployment of the kernel module, because Magma has very strict convention of which interface name is doing what. So ETH0 and ETH1 as interfaces are dedicated to the communication. One is the S1N1 interface, the other one is the SGI interface. And that's the place you need to pay attention to. The rest is just simple deployment and simple scripting. So you don't need Ansible or anything else to succeed on that.
Okay.
Yeah, and you can think of also deployer as just a simple way to bring it up the first time.
Correct.
Once you get it up, you're going to be using whatever Kubernetes or Docker management tools and
Manage it
processes
after.
you want to use for it. So what you already use for it, that. So
Correct.
Yeah.
And
Okay.
with the initiative on which Nitin and his team is working for eBPF, that will be made even simpler. So they are removing one of these big prerequisites on the installation. So then the installation will be even simpler than what is right now.
All right. So that's coming in the 1.11 or 1.10.
That's the I mean, if you go back on this recording and you see me speaking in the beginning, I've placed it in 1.10. But if we are splitting 1.10 to 2 releases, that will come into later release 1.11.
Okay, cool. Thanks.
Yeah.
Other questions? Is anybody curious about the introduction by Jordan? I'm going to go through each item and ask for questions on them. For the introduction by Jordan, call for any questions? Thoughts on the 1.10 release? Magma India. I'm curious about what is the community like? Are there like meetups or how does it work?
Yes, we do the couple of meetups in in University of Delhi and the institution around that in academic and with the partner that we have already working with us like NetWeb and CoreEdge, multiple partners we have. So we do couple of events, and we have a community that works on the Magma process. Like currently we are working on the eBPF. The community member is also working on the PQC implementation and the ORAN integration. So this is how we are doing this in.
And there's a particular university?
Yeah, we are based in University of Delhi in India.
Anybody want to talk about the mentorship program? Documentation?
I'm a bit curious on the kernel applications inside the projects because I'm kind of specialized myself in kernel and so on. The last 6 and 8 months I've been studying and patching kernel. So what are the applications of, like, besides the eBPF that was shown by the
Well, eBPF is initiative for us to get out of the kernel. Current application of the kernel, you have two critical modules which we need to inject into the kernel. One is dealing with the GTPU tunnel, so it's encapsulation decapsulation virtual interface, and the other one is the vport for Open vSwitch. Because Open vSwitch, in order to manage the tunnels, it needs the vport module. And that vport module is going to talk to the GTPU module, which is going to talk to the network stack of the kernel in order to encapsulate and decapsulate the packets. It's a good design for the, let's say, something like 10 years ago when it was done. Currently, it's not so good design because you can achieve the same things without injecting things into the kernel by injecting eBPFs. And that's where the initiative from Nitin arrives. They are going to remove this GTPU encapsulation, decapsulation logic and place it in eBPF, which will allow us even to improve the Kubernetes deployment. Because currently, for you to deploy Kubernetes, you need to have a node which is prepared with the kernel modules in order for the Kubernetes to work. When we have the eBPFs are going to be injected in the kernel dynamically without necessity to prepare the node. but if you want to contribute from the kernel perspective, I mean, Magma can benefit a lot on the scheduling. If you want to work with traffic shaping and scheduling, this is one area where things should be and could be improved. And another area, it's into the, we are using lots of traffic shaping for the QoS. And there are scenarios which 3GPP would require in 5G, which are very difficult to be achieved with the hierarchical traffic shapers. So that's another place to contribute in the from the kernel perspective. I mean, me as well being with the kernel development in the mindset, that the best two areas where we need contribution and where we can have a big change. I mean, big you can make big difference in the performance and the deployment of the product.
That's a
Thank you.
fascinating
Looking
direction.
forward.
I wonder how we can follow up and turn it into something. Andre, I'd encourage you to write a proposal, like stick something in the agenda, like make
please.
sure it doesn't get lost.
Okay, okay.
Yeah, please, and please feel free to contact me. We can have more discussion on, if you have ideas, we can iron them out and then just bring the proposals.
That's it for time. Thank you to everybody for joining us.
Thank you.
Thank you, everyone.
Thanks, everyone.
Thank you.
Bye-bye.
Bye.
Bye-bye.
Goodbye now.